our controller has no idea what the valve is really doing. When I disconnect our data from our actuator, so from the valve body, so to speak, it will have no idea where it is. And exactly this was the problem.
Welcome to another CO2 Monday in the Refrigeration Mentor podcast. Once again, I want to thank you guys for taking the time to come and hang out with us each week, learn a little bit about CO2, learn a little bit about technical knowledge, and learn from the experts from around the world. This week, I have a returning guest, a good friend of mine I've met quite a few times. We talk all the time, just learning from each other, growing from each other. Timo Kaufhold from CAREL. He's out of Germany. He leads all their training out there. He's a marketing director or manager. He takes care of well, I look at it as, because he's the go-to guy when we're talking about electronic controls. Timo, welcome to the podcast.
Thank you, Trevor, and also hello and welcome to everybody here live and in the podcast or on YouTube or wherever you are joining us. Yeah, thank you to be here again, and thank you for the short call. So it's every time an honor and great fun to be here with you and sharing all the knowledge with all of you guys.
So the last couple of videos we did, huge response in the podcast, because we talk about technical stuff and we dive into those things that manufacturers want to hear about, right? And they want to learn. And today we're going to dive into some troubleshooting for some of their CO2 products. So this is, I know we talked about it a little bit. It was some issues they were having in the field last week. And we're going to take a look at how to read this stuff and how to actually troubleshoot a system when you're in a CO2 system, when you start to run into issues. I'm super excited to learn a little bit more about this, because this is what it's all about. Is if you're in the field as a technician and you run into a problem, what do you start to look for? And getting that understanding is so key. And I'm excited to learn.
Yeah. And every time I speak with you, I learn also a lot, because every time you show or teach something, you learn it twice. So, where should we start? Let's start from the top. You see, for everybody who is watching the video or is joining us directly with the video, you can see two products direct in front of me. We have one controller directly in the front of me. This is our P-rack, our controller for the compressor rack, at least, for transcritical applications. And the other one, more to the left of my side, is our monitoring and supervisory system, our BOSS, the large version for supermarkets. And these products are really two of my favorite products, and especially when it comes to troubleshooting, it's really awesome to work with both of them, because when you have a monitoring system and a kind of controller who's able to speak to a monitoring system, you have a lot of data. And this is really something that is fantastic if you're doing some troubleshooting or maintenance or whatever you are doing with your running application. If you have all the data on your fingertip, more or less, if you have a mobile phone or a tablet you're working with. And with these two products, we were able to solve a problem remote with our customer. And this is really fantastic. Yeah, let's start with a short look into the problem.
Let me ask you a question first, though. So
yeah.
if a contractor or manufacturer builds a piece of equipment and doesn't have the monitoring system, can you go into the controller and still get some information and graphs?
Yeah, it depends.
Okay.
And every time the big answer to all questions are, it depends.
That's refrigeration for you.
Exactly. You have many possibilities to go directly into this controller and find information and to read some log graphs out of it. If you have your laptop and you connect it to the controller, you can see some live data and even some stored data, depending exactly on the system, how it's set up, and what software you are using. What we are now doing is we don't need a dedicated software because we have our monitoring system, and we only need any kind of device that is able to surf in the internet, so with a browser on board, and you can see all the data. And this is something we will see in a couple of seconds. So let me share my screen. We start and dive directly into our issue. You see here's something red, a color we don't like.
Yeah. Let's explain what this layout is, because some people may have never seen this diagram here. Why don't you just dive into the layout so people understand? And we know red is bad. So this is the boss. This is the monitoring system that will collect all the data, I'm assuming, from the controller. And then this here is what's going to help you troubleshoot.
Exactly. Let's start from the top and go even a bit more in the overview. So what we are seeing now is the starting page for this customer. You can change it. You can have different controllers. You can change the look and feel. You have many possibilities. And this is just the standard view we are using here for this dedicated customer. You have a lot of cold room controllers and cabinet controllers here. These are our MPX Pro. And what we are seeing at the moment is we see a lot of these MPX Pro on one page. All of them are green. That's a good sign for us. Green means everything is working well. And we see also the first information of some temperatures, what is going on here. So you get a real good idea where is each of these cold rooms and cabinets running.
So if I logged on my phone or on a computer, this is kind of what it would look like if I'm logging into it?
Exactly.
Perfect.
So I'm just logged in with a browser remotely to this running application. So let's dive into our rack controller, into our P-rack. Now I have the first detailed page entered, even a kind of overview of our running rack with the main informations or some of our informations we selected for our customer and with our customer. And now let's go to the trends. And here we can see the trends going back many weeks and months.
Pretty straightforward, 2 clicks. Click on the Transcritical rack and then click on trends.
Exactly. Now the page have to refresh until we see all our log graphs. This can take some seconds because I'm logged in remotely. And this is how our rack is running at the moment. We have a lot of information here. This is also something I can select. But first, I would like to go back to our problem. So let's go back. Something in this area. And what we can see now, we have many informations here on this page. We have our discharge temperature, gas cooler pressure, gas cooler outlet temperature. We have the opening. We can see the opening of our HPV valve, even the flash gas valve. We can see all the necessary informations, and we can select what we would like to see. So this is absolutely in your hands. What would you like to see? You can select it, and it's everywhere here. So
the big thing is, Timo, like there's, depending on who it is, some people, like for sure, you'd love lots of data on there, seeing all this stuff you'd understand, but this takes time. Understand what you need and what you're trying to troubleshoot, because for someone new to this, when they look at this, this is going to be like, oh, what is all this? Is overwhelming. But really take the thing, the pressures and temperatures that you know, and then start working from there, and then grow this, these trends. So you start to understand what it looks like to you. And over time, you build patterns in your mind, and you can start to see things, because especially in the red, you're going to point out in a second what they are. But just be aware that you can add lots of lines or graphs and reduce them, because that's a big thing. Some people go in and first thing is like, oh, there's too much here, I don't understand. You can pick what you want.
Absolutely. And that's totally simple. You can just click on off button and select or deselect the informations you want or you don't want to see. So maybe some of these informations are not interesting for us at the moment, or for the thing we would like to do. The external temperature, the outdoor temperature could be interesting. Let's leave it. Leave also this inside. And as you can, everybody who's watching the video can see we are selecting or deselecting and now we have a lot less data here. And how Trevor said, I started with one information. I would like to see one information or two or three. Maybe sometimes you would like to see your valve opening, your superheat, and your set point for the superheat.
Yeah.
This could be interesting. Maybe you would like to see other informations. And now we are here and we see our rec, our PREC controller, and the informations. And we have something red here. So red is a bad sign. And if we scroll with our mouse, let me take this one and highlight it a bit. So when we go here in the red area, we see also we have a generic alarm for compressor 1. We have a high suction pressure alarm. We have high condensing pressure alarm. So a lot of alarms are going on here. And now we need to know why. Why do we have here so many alarms? So
I got a question before that. So it says it's a generic alarm for compressor 1. Can that be changed, that name? To like oil failure alarm or anything like that?
Or high temperature alarm or high pressure alarm or whatever. We can change this.
Okay, perfect.
Everything you see here can be customized.
Fantastic.
But you start with the basic setting. That's also a fine thing. You don't need to build everything from scratch. You have a basic setting, you start with that, and can optimize it for you and your needs and the needs of your customer.
Exactly.
So now we zoomed a little bit into our log graph now. What we see is we are red here. Here's something, one line. I highlight this line. This is the HPV valve, our opening in percentage. So here we see a normal behavior. We know it's normal because we have seen it many times in the past.
But here at some point, 34% open, between, I've seen lots of racks between, like 40, 30 and 60, depending, you know what I mean? You don't want to close for sure, because you're going to open those reliefs, and you don't want it wide open because why is it wide open? Is it not getting enough gas? Is it short? And there could be lots of different reasons, but.
Exactly. And we see something. Something is we can see here. We have here at this point opening up to 100% of percentage of this valve.
Yeah.
That's not okay. And it's directly before we have our alarms. So here's something we have to take a closer look on. And we see in all the other hours before some stable regulation in different areas. In our fan management, we see some stable informations here when it comes to the set point, because we shift also our set point, and also when it comes to the gas cooler pressure. But at some point, everything goes up, everything that belongs to our gas cooler. So, and to the high pressure side. So here's something wrong. So let's take a closer look into this area. So we see our controller is regulating something, and he tries to avoid a high pressure alarm. So we have here also a high pressure prevent alarm. But nothing helps. Our high pressure valve is open to 100%, and we still receive a high pressure alarm.
Yeah. So that's an issue, right? Your valve is wide open and your pressure is still going up.
What could it be? So you have different things you can take a look on. Is our fan from the gas cooler running? We see it here more or less in our log graphs. It is running. There are different indicators you can see. At the one hand, we have our fans, here the current and the percentage of our fan speed, 33%.
Oh, that's cool.
So we see.
So we know what it's running. The fans are running.
And they don't need to run at a higher level. So we don't have a high temperature issue or something like this in our gas cooler. Maybe sometimes a gas cooler is standing outside, and you have some paper is flying around, or some plastics are flying around and get sucked by the gas cooler, and it's completely closed the gas cooler. So then you also run into high pressure problems. But we would see it. Our fans would go higher, and we would see also the difference in the temperature, in the outlet temperature. And what we also would see at this moment, if we had some other issue, what our receiver pressure valve is doing.
And so those fans, they're run off the outlet temperature or at ambient temperature through the controller, or both? Pressure, temperature, ambient.
This depends on the setting.
Okay.
But here in this setting, it depends really on our gas cooler temperature and pressure.
Okay. So as that temperature and pressure goes up, the fan speed should start to ramp up. So your ambient temperature goes up, it gets really hot outside, those fans should start ramping up.
Exactly. So the fans doesn't ramp up. Okay, what could it be? If you take a look really on this clock graph, there's only one point that could be this issue, our high pressure valve. It's the only thing that could be really make these kinds of problem without producing other problems. So our blocking part is between our compressor and the high pressure valve. Would it be after the high pressure valve? We would see it directly in our receiver pressure valve. This would open.
Yeah.
Okay.
Because we see the gas cooler pressure that continues to rise, so that pressure transducer seems to be working. It's not like the pressure transducer would be out, for those who are watching. And then your outlet temperature, you see that continuing to rise as well a bit. So all telltale sign, like the temperature probe at the outlet's working, the pressure probes are working. So this is the process of elimination. This is what you're using the trends for, to get an understanding. So you don't just jump, oh, must be the pressure transducer, let's get some transcritical gauges and put it on. This is why you read these trend graphs.
Exactly. Let's change the perspective and go to another presentation and take a look into a standard transcritical booster rack, and where we have our different parts. Now, what you can see is a standard transcritical booster rack. We have here our low temperature compressors. Here's a medium temperature compressor, even the parallel compressor. And now here on this side, we see our high pressure valve. And we only can have a blocking part between the high pressure valve and our compressor outlet, high pressure side, so to speak. Why? As we told you a couple of minutes ago, if we would have a problem after our high pressure valve, our flash gas valve, receiver pressure valve, however you would like to call it, this would bypass more to our suction line. Yeah. So this is the part of elimination. To do this, you really have to know what each part is doing, what the job of each single stage is doing. And yeah, you simply can go out and can say, we have a problem on this side. This has to be this high pressure valve, but you could be wrong. If you don't have an idea why this would be the problem, there could be a broken probe. There could be something else that is the problem. And many people out there are simply going out and exchanging parts, yeah, without knowing what they are doing. Sometimes they're right, sometimes they're not. But to be more on the right side, you have to know before you go. That's the part.
Yeah, I love that. It's so true, because the more I learn, and I continue to learn about CO2 and refrigeration and commercial refrigeration, the more I understand each and every component inside and out, it makes me understand the system as a whole, because one moving part can affect 3 or 4 other things. It's kind of like the compressor. I do compressor trainings all the time, and that there takes the punishment of 90% of the components in a system.
Yeah.
Right. But we see the compressor, oh, that's the problem, but really something else in the system. So you want to really take your time to understand each component. I love that, Timo.
And the fantastic thing with a monitoring system, you can take a look back into your history, on the history of these components, of this application directly, and you can see where the problem starts. So now we have found a problem. There's a blocking valve. Okay, so far so good, so easy. The valve.
So you said for anything from the compressor to the high pressure valve. So anything in that line, it could be something that could be causing that issue. So now we got to figure out what's in that line now.
Exactly. And we figured out directly here, it only can be this high pressure valve. You can see it on the data. And the next thing is you have really to go out and to check what is wrong with this valve. So the service guys were out there. They replaced the valve. They found the issue. The valve was blocked. Now we are analyzing why it was blocked. It seems there was something inside of the valve that don't have to be there, but we will take a look on it dedicated, and we don't want to talk here about it. So so far so good. They replaced it.
Okay, let's talk about that though. Let's talk about, because there's different valves, different manufacturers. Did they have to cut the whole valve out? Did they have to just isolate it safely and then just unthread it? What was that process like, so people know if I ever have to change a valve, what do I do?
Yeah, perfect question. Let me change my place of working here now. Let's go to this place. And we are talking about a high pressure valve. So it's pretty exactly this one. The good thing of this valve is it is a demountable valve. So you don't have to cut it out completely. Okay.
This here is a welded in valve, stainless steel welded. You're not brazing this in, correct? This one here will be welded in. Because here in Canada, it's all stainless steel on the high side, and that would be a welder come in. So most refrigeration technicians, we're not welders, right? We braze and stuff. So we would have to actually cut that out if you cannot take it apart. So this valve is one that you can take apart. Cool.
Exactly. This is the good thing. It's a demountable valve. It's one of our smart valves. So you can simply exchange the whole thing, and you can leave the body inside of your application. That's the easy part. So they replaced it, and this is how it looks. But this was just one half of the issue. After the commissioning, we faced another issue, but that's a different issue. Let's check also this one. And this is also a part where we can say, know before you go, know your application. And if you work with some things, read the manuals, watch the tutorial videos, get an idea, and ask the right persons for advice or help. And now let's take a look. Let's go a bit back. So
the gray portion there, that's where they would have the system shut down. They have it isolated at this point.
Exactly.
Nothing's running. They're doing their job. They're doing the repair, the replacement of that valve. Yep,
that's absolutely right. Then they have replaced the valve. Now it's not really good to see at the moment because we have still some issues here running at the application, but at the end of the day, everything was running. At the end of the day, we can see where the yellow or orange color is gone. But what we saw now is when we take a look on the opening percentage of the high pressure valve, we see, and even if we scroll more forward for the next hours and even for the next day, we always see 19% opening. In this case, for this application, this is our minimum opening for the high pressure valve when our rack is running. Why we have this minimum opening? Simply because we need a clear signal from our gas cooler to all the sensors that are afterwards. So 19% minimum opening, can be true, but maybe we have other problems.
Not for a day. Like if you're running, I've never seen a valve, any electronic valve in a process like that where the load changes all the time. Doesn't matter if it's a case valve, you're not going to see the opening percentage just stay there simply. Maybe a super process plant that is exactly to the T, but any pressure or temperature differential and change will change the percentage of the valve to try to maintain your set point. So a day running at that exact same percentage on any electronic valve for me is like there's something up there.
Even an hour.
So even an hour. Yeah, I know.
Something has to be wrong at this moment. And what we also see is the opening of our receiver pressure valve. So the first thought was maybe we don't have enough refrigerant in our rack, so in our complete application. Could be an issue, maybe. The guys from the service don't have enough CO2 in their car to fill up everything. Could be one part. But what we see, our flash gas valve is working. Even if I don't have the right gas cooler pressure, I have to regulate my my flash gas. The flash gas valve has to regulate. So these two informations don't fit together. On the one hand, if I have enough refrigerant in my application, in my plant, the gas cooler pressure should be higher. And then it's also no issue that my flash gas valve is opening and closing and working. So what could here the problem be? So I don't think, and I was absolutely clear at this moment, it's enough CO2 now in our application, because all of our cabinets and expansion valves are working fine. We receive our temperatures. If we have not enough refrigerant in our application, we would not reach the temperatures.
Exactly.
And the next point, we wouldn't have any issue with our flash gas tank or receiver, with our receiver, if we have not enough CO2 in our application. The flash gas valve wouldn't have to do anything to bypass and to keep the pressure low enough in our flash gas tank. So what could be the next problem? Yeah, one more time. Maybe something is wrong with our HPV valve. Or maybe not with the valve. But now I would like to show you something. Before we answer this question, where is exactly this problem? We have to understand how a controller works and how the valve works. So one more time, let's change to this beautiful place. And we take a look on something I have prepared. Now we have here a little simulation box. This is a standard expansion valve driver, EVD evolution. I have connected here my HPV valve. Let's open this valve. And now I will start the regulation, and we will see the valve is opening at the moment, how it should work. So that's great. So keep in mind, we have a valve that's only open by the minimum percentage by the opening. Our controller has no idea what the valve is really doing. When I disconnect our data from our actuator, so from the valve body, so to speak, it will have no idea where it is. And exactly this was the problem. So the installer was changing the components, was working the first time with this kind of application, and he was not really sure what is going on in this application. Why is the valve opening to 19%? And why it's opening more and going back to 19%, why he is filling up the application and the refrigerant. And he was not sure, is the valve working or not? And he removed the red hat from the body just to see, is this working? And what happens if I put it back? He was thinking about a magnet valve. And he expected to hear something like a closing and opening of the valve. But this was not happening because we are not talking about a magnet valve. We are talking about a stepper valve. So he removed it, put it on, and was thinking, okay, I have no idea. I have to call somebody from CAREL or anywhere. I need some help. We helped him through the basics. And then we found some issues. And in the next point, we were thinking, okay, after we have checked, refrigerant is enough in the application. The rest is running well. Our receiver pressure valve is doing what it should do. And everything is here running perfectly, except the HPV valve. So we said, okay, we can do the following. We can turn off, we can take a look. Normally, the application is turning off in the night because we don't have some loads. And if our controller stops regulation, he will reset all the valves. We said, okay, let's check. If we reach this point, fine. If not, we will do a restart next day because we don't want to interrupt the working of the application in the work days. So we saw, okay, nothing is working. And let's scroll some days further or some hours. And in a couple of seconds, we will find the right point in our log graph. So you can also see the difference between night and day.
Yeah, big difference.
Yeah. And now.
And this is why it's important to spend time with the graph. So if you're out there and you're doing a maintenance or you're doing a service, pull this stuff up. Take a look at it so you get a better understanding. And really, the big thing is when it's running properly, that's when you should start learning. Start looking at this. I know this is running here. We know it's this temperature outside. We know it's this time of day, and this is where it's running. Look at it at night. Look at it at different times of the year, when it's winter, when it's summer. And this is where you start to grow your knowledge and you get better at it and you start to see these trends. And that's why it's called trend graphing. So you start to understand what is happening to that system. Because what I've been seeing, and it even happened to me, I'm always going to calls to put a fire out, but I didn't even know how it ran right in the first place. You know, so I've thought of it, but after I start learning trend graphs, this is where things start to change. You start to see things, and it helps you.
Exactly. And here, exactly at this point in the graph, you can see we are running before a dedicated point. We are running still at the 19% opening of the HPV valve, but now you can see also.
Yeah.
Make it a little bigger. The point where I turned the application off remotely and I turn it back on. And from this point, the valve is regulation proper. Right at the point.
44, 45%, it looks like. Going, yeah, because you were at 19 the whole time. Now it's starting to change. Yep.
Exactly. So many questions for the installers, but everything we could clear all this question, and we could show to him how it works, how it started, how we solved this issue. And he has learned a lot at this moment because you can see at one point all informations in one overview. If you are in the front of your application, sometimes if you just have your measure instruments from your car, you have to take the one instrument here, measure, take a look at it, take it to another point, and you don't have it all at the same time. And this is important, to have all information at the same time to make a clear statement and to understand really what is happening here. So this was one problem we could solve.
And so let's talk about, so basically what happened there when the new valve was put in, it wasn't reset to its zero positioning? Is that what happened?
Not really, not really. The problem was our friend in the service was a bit stressed and nervous,
Yeah, that's
and
fair.
he put up the motor of the valve while it was regulating. And he was not thinking about the controller has no idea where the valve is really working and opening. My controller was thinking, okay, everything is running. My valve is closing at the moment, and now it should be at 90%, and everything is fine. But in truth, the valve was in an opening percentage of roughly 30%. But the controller was thinking, I have reached my minimum allowed opening amount, and I'm not allowed to close it more. This was the problem.
Okay, so that's a good point, because in a lot of electronic valves, there's no exact feedback signal, so it doesn't tell you where you're to and from. So pulling that off, it was still adjusting, thinking it's moving at that point for, just say it's a minute off or 30 seconds, whatever, and you put it back on. Now you're out of that, you're at a different position. So when it's put on, then now it's not regulating at that position it should be. And the solution here was when you went in and disabled the power. Is that correct? So you shut it off, the controller. It shut everything down, because this would be the rack controller, correct? It's not a separate controller. This is all built into one, right?
Exactly. We are talking about the rack controller.
So you went into an emergency. Would it be an emergency shutdown? So what would that process be for a technician? Because when you shut down a rack, you don't want to shut down a CO2 rack unless you know what you're doing, right? Because if you shut it down, it's the middle of the summertime, it's 110 or 40 Celsius out. You could pop off or blow the reliefs or open a relief up. So you want to just be aware of that when you're shutting down a whole system, because it does take time to start it back up. Because it could take 5 minutes, 10 minutes, 15, depending on the thing. Could take 20 minutes to start your thing, your controller back up. And I'm not sure exactly how long it takes to set yours up. The more components, the longer it would be, I would say, on the rack.
Yeah, exactly. And it also depends on the series of our controller. The new controllers are pretty fast. They're a high-speed controller. They're starting pretty fast, and even the shutdown procedure is really fast. Normally, with the old version, it can easily take 5 to 10 minutes, and the new one can make it in 1 to 2 minutes. So that's the difference.
Oh, wow.
Even we know our controller we can stop the regulation. So everything slows down, will be shut down. Every procedure is done we need to do to stop regulation safely. That's a different part to just switch off the power.
Yeah, exactly.
Even this is something we had to explain to the customer and tell them, I know what you're doing and it has worked. Absolutely, I'm on your side. But next time, do yourself a favor and stop regulation and don't simply turn off the power. This can bring some issues in the future. Not with our controller, but maybe you will come into some high pressure issues and blow up.
And the easiest thing is for anyone who's out there that works on anybody's rack is really you just pump down that rack. So what happens is that the manufacturer of that equipment designed them, all the big manufacturers, they design them good. They do a great job. You shut, just like you're working on a standard refrigeration rack, you're pumping it down the same way. You shut the outlet, your liquid outlet, and then your flash tank receiver should start to fill up. And then you should start to hear the compressor start to cycle off, because you have you're draining the whole floor of all the refrigerant. There's different ways to do it. This is just one example, but you also have to watch that flash tank, because if someone did overcharge it, maybe you have too much refrigerant in the system. But these are things that you need to learn. And this is what we talk about in the CO2 course that I put on. But you have to understand that, but you pump it down and then it should start to isolate and the shut off properly. And then you're isolated. That system should be isolated. And then if you have an auxiliary unit, some racks have an auxiliary unit. You could either turn that on or it automatically turns on itself. So it can just run for a long period of time. And then that's when you would shut the power down. Is that the kind of the steps, Timo?
Absolutely.
Yeah. Awesome.
So another thing we saw on this plant. Let's jump into one of the other cold rooms. Okay. And Pro cold room. That looks great. We should be on the right side. Yeah, well, yeah. Same plant. Low temperature cold room. Everything was running more or less, but now we saw a high temperature alarm. We were still monitoring this application, so it was quite a bit strange. We have only the high temperature alarm on one cold room, and all the other cold rooms were running. So we took a closer look into this cold room, and we can see a lot of information here. We have our working superheat set point, really the set point. We have our superheat. We have the working set point. We have all the informations we need from our cold room: air inlet probe, air outlet probe, room temperature probe, etc., etc. Even we can see, are we in defrost? Are we in regulation? Is the fan working? Do we have smooth lines working? Smooth line is a special function we are using to keep the temperature in a cold room or in cabinet as stable as possible.
So, that's so I've never heard of that. So is that like an algorithm built in? Like, how does that work?
Yeah. It's a small algorithm built in. And what we are doing is when we are close to the room temperature, to our set point, we start to manipulate our superheat. So the idea is to make it superheat higher the closer we are coming to the room temperature. So we will never reach a cut-out temperature. That's the idea, more or less. We can talk about this in another in one of the other CO2 Mondays.
It all of a sudden, so I love it.
How to work with energetic optimization.
Yeah,
but the problem here was really, why is this cold room not reaching his temperature, and why is the regulation temperature so strange in the behavior? We were checking everything remotely. Let's make it a bit bigger. And first idea was, not enough refrigerant. Okay, we can cut this topic out. We have checked this. Our application has enough refrigerant. Next point, maybe ice on our evaporator. The complete plant was standing still and all the rooms were warm in the last days because it was really after our shutdown. It could be ice. But after a direct check here, we can see the temperature difference between air in, air out, or defrost temperature. That's our evaporator temperature. The temperature difference is too high to have ice on our evaporator. So this is not a problem. And we checked a little bit more and we see some strange behavior of the of our fan. This below here, I will highlight it for everybody who is watching. This is these blue parts here. This is the behavior of our fans. And the stop signal of the fans comes from the door switch. So something is wrong there. So we checked this, called the customer. Okay, we see here an issue. Do you have an idea what it is? Do you have the door open or what is the issue? And they told us, door open more or less by accident. We have broken the door while we were transporting the goods in and out. Yeah, the door was damaged. So this is our problem, and it will be repaired.
So that's it there. So you got to think on low temp applications. if you don't know, when you open up the door, you're going to want to stop the fans. And that's what it was connected to that door switch, just like you said, because you could run into lots of issues just like this.
Exactly.
And so it's strange though, like how it was open and then it was closed and open and closed. They must have been at that point they were trying to shut the door. That's what it kind of looks like, right? And like they must have been, the relay was opening and closing, open and closing. They couldn't fix it. Then all of a sudden it's just open, it looks like.
Exactly. And even the behavior of the temperature, of the room temperature, you can see this is strange. It's not a normal behavior of a room like this. So you really have a lot of warm air into this room, transported many, many times. Yeah, and this was also something you can see in this point.
And that's awesome. And this is from the monitoring system. And this is why it's important and key. Like I said it earlier, get in and take a look at these graphs, get an understanding of what they do normally. And then when things like that start to happen remotely, because more people are going to be working remotely. It's happened. I did it 15 years ago. I was working, we could dial into stores then, and it's just getting more advanced where when you're working with your customers, you can see this. And then you can start to tell stuff even before you get to a job site. Like you could right there, you could already know, okay, well, it's not refrigerant at that point. The airflow is good. The in and out is looking good, but the temperature keeps to rise. What's going on? And then that was a good spot on seeing that relay, the fan relay, open and close, on and off, on and off, on and off.
Exactly. And we have many, many other examples of this in the past. We had some cabinets that were not reaching the temperature starting from the summertime. And we were checking what is the issue. Also, one of the first thoughts is maybe missing refrigerant, maybe ice on the evaporator, maybe the stocking of the goods into these cabinets are not in this way how you should do it. These are all things they could be, but finally we found out for the summer month, we were too high in our evaporation pressure. Simply to the optimization of the energy consumption. We could adjust this simply by reducing the superheat of our valve in our cabinet, reduce it from 8K to 4K, and keep the high evaporation pressure for the optimization of our energy consumption. This is something you can see in the log graphs. You can combine also different informations. And this was also something we did in the past when it comes to energy optimization in the monitoring system. You can also set.
And I just want to add to that, and that's a skill, right? If you're a technician out there and you got a few years in and you want to learn, you start with the trend graphs and stuff like that. The energy optimization, that's going to come with skill, like years of experience working at this. Like Timo's, he's an expert at it. So it's looking at these graphs, and it does take years. So don't get frustrated if you're working on a system and you don't really understand, because it could be one of many things. It could be actually the store itself doesn't have good conditioned air. The humidity could be super high, or there could be lots of many different things, right? The temperature in the store could be really high and causing this stuff. So on the energy optimization side, it takes years, and then just learn from people that do it, just like Timo.
Absolutely. And if you have some applications running outside, start with the monitoring of the running applications and maybe place 1 or 2 sensors more. We also have in some of our trial stores temperature and humidity sensors in the store or even in the storage rooms to see if anything is running out of control. We can see what is the issue. Exactly. What is the environment? Where are we working? What are we talking exactly about? And to check with our little application, I created a virtual device, so it's called here. In this virtual device, I can put any kind of information inside, and my boss our monitoring system boss is behaving with this device like a real device. But what I did, I was taking the superheat from my medium temperature line from the PREC, put it here inside in this device. I also was taking my superheat from 3 cabinets here inside and was checking, is everything working fine? Maybe you can say, why did you insert it? Why have you inserted the superheat from your rack inside? So superheat of your suction line. Pretty easy or pretty simple, because I want to know if I'm optimizing my superheat and lower it more and more. I would like to avoid to bringing the superheat in front of my compressor too low or give my compressor some liquid. That's the reason why I was bringing all this information in one log graph and look at everything at one time.
Yeah, that's awesome. And that makes sense. This is what you do. This is more advanced stuff, right? When you're taking different points, trying to understand a system. Once again, don't get frustrated with it when you're new with controls. We said it early. Timo said it earlier. You got to read the manuals. It takes a lot. You got to play around with them. It's not like you just read the manuals and you'll know how to do it. You got to go and play around with it and see it in action. Understand what each parameter does. And in controllers like this, there's a lot more parameters in your standard controller. So take your time to learn it and understand it. If you don't know something, write that down in a book and make a list of things that you got to ask the manufacturer that you don't understand. And the information's out there. Somebody wants to help you to get that knowledge. So it makes your life easier. So you're not stressing out there in the field, because that's what most manufacturers want. They want the product to work seamlessly and the people working on it very confident and comfortable.
Absolutely. So take your time, focus at one thing at a time, and then widen your view, widen your range, and widen your knowledge, and stay in contact with everybody and learn from each other.
Yeah, I love that. And share, like this is it. When you teach people, you're going to learn more, and that makes you learn a bit more. We got a couple questions here. Can you navigate the controller screen and reset the alarms like you can via IP with PGD? I'm not sure what the last part, right?
Yeah, exactly. PGD is our display. So you can also reset all the alarms. This is possible. You can see everything here and can do everything if it's allowed in the user administration. So we also can limitate some user. Not every user should be allowed to do everything. Some end customers, as example. Yeah. So you can do this exactly. Yeah.
And one point to that too, like I highly recommend, if you're working on these systems, have your own login and your own password, and don't be sharing that stuff. Like I worked at places where everyone had the same login and password, and you know what I mean? This just takes away from what you're learning in a way, because it's great. You need to get someone out of a bind, but if everyone has the same password, you don't know who changed what, and that you're not going to learn that way.
Exactly.
Mistakes happen. But if you don't know you're making the mistakes, how do you learn from it? That's the big thing.
With passwords, it's the same thing with underwear. Don't share your underwear with other people.
I like that. We have another question. The controller during normal operation does not perform automatic calibration once per period of time?
It does if it's working normal. Yeah, it does. Okay. But this wasn't behaving normal, so we never reached the point where it could do the calibration. It was not allowed to do this. So
19 was that bottom line. So yeah, awesome.
Yeah.
This was amazing, Timo. Timo, how can people get a hold of you, learn more about this product, and find out more?
You can find out more if you follow me on LinkedIn. This is one thing. You can find a lot of more information on the CAREL homepage, carel.com, and even on the other dedicated CAREL page like Netref and many other CAREL pages. Or now I have to do some ads for myself, more or less, or my work.
Definitely do it.
I was doing a lot of work in the last time, and there will be much more work in the next month and many next times. everybody who's joining us with video, you can see now our e-learning platform we created here in CAREL, Germany. And I am the guy who is creating the most of the tutorial videos. You can take a look in each of these. The complete platform is for free. You can see a lot of information. We have complete courses. We have also course material inside, and we will create more and more and more and more content, especially to natural refrigerants, CO2 applications, and so on and so on.
Awesome. That is super awesome. Once again, share this. Go check out this learning platform. Go check out and connect with Timo on LinkedIn. Check out their webpage. Once again, thanks everyone for taking the time to come and hang out on CO2 Monday. I learned a ton today. Once again, this is just so beneficial for me because now I can share this knowledge with other people. And you should share this too. Share it on Instagram, LinkedIn, share this video from YouTube. And if you're listening on the podcast, thank you so much for taking the time, and we'll see you at the next CO2 Monday.
Hey, thank you for watching this video. I do hope it is bringing you a lot of value. If you are looking to grow and build your refrigeration teams and want them to learn CO2 refrigeration, head to the refrigerationmentor.com website, click to contact us, and let us know how we can build a culture around training inside your organization. Let's get a conversation going.